But we begin with Archives Director Susan Kinsella, reading excerpts from Dan Knapp's interview with Mark Gorrell, Dan's college roommate. Susan is living the slogan, "The show must go on," as she reads whilst arising from her sickbed, recovering from COVID. So with that, Susan, could you take it over?
Sure, thanks a lot. First, I should just mention that the Recycling Archives is interviewing lots of the people, especially from the early years of recycling, in order to build up the history that we never had time to stop and gather and learn from the kinds of experiences that people had putting the earlier programs together and the visions that they had for it. Tonight, I want to read about Dan Knapp's interview with Mark Gorrell, as John said. So let me start with that. In 2010, Dan Knapp of Urban Ore in Berkeley, California, conducted several interviews with his close friend, Mark Gorrell, as Mark was dying of cancer. The interviews added up to about 12 hours and nearly 200 pages of transcription. Dan and Mark had met their first year at the University of Oregon. Dan ended up getting a PhD in sociology, while Mark became an architect. During nearly 50 years that followed, they became best friends, shared houses together with roommates, moved separately to Berkeley, then met their wives and brought them into their creative projects. And through it all, they collaborated on recycling design projects together that expanded the vision and the potential for actual working recycling centers that result in true zero waste. The key to what felt to them both like a magical working relationship was the mentoring that they gave each other in their separate areas of expertise. Dan's focus was on real life experience with people's recycling needs, their quirks and behaviors that would need to be accounted for in a well-designed recycling center. Mark's focus was on how to envision, plan, and draw the detailed plans that would make those insights work best in a physical environment. Putting these together, they created visionary plans time after time for different communities, different sites, different needs, and different parts of the globe. Dan tells a story about why their approach was so essential, yet considered innovative. It has to do with the battle he and Mark conducted together, along with many others, against a burn plant that originally was voted for unanimously by Berkeley City Council as the solution and replacement for their Bayside landfill that was ordered closed in 1983. Dan says, "I remember the city had an architectural engineering firm that they contracted with for burn plant design. They put recycling into the plan, but it was tiny. They only gave it about 1/10 of the site, not enough." Mark says, "Yes, recycling was given a little teeny strip. It was way too small. No recycler looked at those drawings and thought they were okay. The consultant engineer's drawings set the stage for a big fight that went on for years." Dan continues, "Our designs were grounded in reality. We learned and improved from mistakes in real time, while the city consultants' designs were built on 20-year projections drawn from faulty data. I remember reading closely the city consultants' report for the future of discard management after the landfill closed. In it, they claimed that plant debris was 3% of Berkeley's garbage. But when I was out there every day working as a scavenger at the actual landfill and watching the loads come off the trucks, I was seeing a completely different reality. So when I had the chance to speak at Solid Waste Commission and City Council meetings, I said that plant debris was not 3% of incoming volume, but more like 25%. My contradicting the engineer's study by showing them slides from their own dump likely helped councilors and commissioners see that their consultants were taking the city into burning garbage without even knowing its real composition. And with millions of dollars worth of investments at stake, this was pretty unnerving. Well, ultimately, the burn plant was put up for public vote and soundly defeated. That opened up the intended burn site to become a recycling mecca. Mark designed and then redesigned the available site over many years as space, equipment, and needs changed. Not all of his designs were built, but from the beginning, as early as 1981, he drew plants that proved that no waste, what later became zero waste, was definitely possible. In discussing their collaboration, Dan asked Mark, "What was I teaching you?" And Mark says, "Teaching is not the right word for the mentoring we were doing. We worked things out together a lot. The mentoring went both ways." Dan says, "Oh, I agree. We'd get into discussions about how to solve a problem. As that process sorted itself out, you would end up doing the visual parts, and I would be writing a narrative that would explain the visuals." Mark says, in your narrative, you would explain how the system would work." Dan answers, "The narrative would describe the project in words. It would explain why we are doing this project right now, and it would say how it's supposed to work." Mark added, "I think we worked very well on those kinds of projects. We did some good stuff." Dan says, "What happened with us was almost impossible to predict. It seemed magical. We would discuss and discuss and discuss until we were really tired of it, and then we'd quit. I'd go home, you'd go home, and then when we get back together, you'd have some kind of solution that would be worked out as a set of drawings so we could see what we'd been talking about. And then I'd say, oh, well, it still needs this to be added, and when this needs changing, and we'd make some modifications. Then I would write it all up, combine it with the drawings, and that would be the report. We did a lot of that." Mark adds, "The process of design usually started with conversation, but after that, it became more solitary. I find that when I'm designing, I have to do that by myself because I'm thinking about 14 different things at the same time, and I need to filter it all down. I don't design very well with someone else there with me while I'm doing it." Dan adds, "As the old saying goes, a picture is worth 1,000 words." And Mark says, "Yes, but I'd say 1,000 words is worth a picture too." Dan said to Mark, "I understand that you're not specialized in the sense of being a hands-on recycler handling a particular commodity type." And Mark, who worked on many other kinds of projects beyond recycling, agrees, saying, "Nope. Instead," Dan says, "you make your architectural skills available to us operators because all material recovery has to happen in a physical space. If you don't design the space, then what happens?" Mark described, "It will fall apart. Order becomes chaos. Incoming things will pile up, closing off roadways and aisles. Everything will get messy. People will be climbing around piles of stuff in dangerous ways. Injuries might make you uninsurable. Customers won't be able to find what they want. These are some kinds of things that have to be taken into account. Each product has to be understood in its own terms: how it arrives, how it's moved, how it's processed, how it is taken away, and where it goes. They're all different. You have to understand how people arrive, what they see, what signage directs them here or there. The public coming in wants to dump things off. You don't want them dumping things where the big trucks are unloading. Inside the processing area, there are different materials being handled, and they have to all be dealt with. I mean, how are you going to get each specialist thing to do its thing without messing up somebody else's thing? The final plan is a conglomeration of solutions, ways to get the whole system to work." Well, a project that Dan and Mark worked on in New Zealand gives an example of some of the real life challenges that they each had to filter down to create a high functioning recycling center plan. And as Dan starts out explaining, Dunedin, New Zealand, is a town well down the east coast of the South Island towards Antarctica. Thanks to Warren Snow, we got to perform an architectural edit on a locally produced zero waste site plan. In this job, we changed most of the functional areas around while keeping the overall idea and the site size. Dunedin was a matter of sorting out the traffic to keep big equipment from running over customers' cars and utes. Utes is what Kiwis call pickup trucks, Dan tells me. It was a small but interesting contract. This job came to me when I was traveling in New Zealand a lot. Warren Snow's Tyndall Foundation had pledged to give money to Dunedin to support their zero waste design. Warren asked me for my opinion. I took a look and said, "This thing's got various problems. Built-in conflicts, services not optimized. It's got material handling equipment traffic crossing customer traffic. It's not as safe as it could be. And the sequence of unloading needs work. Mark and I could redesign it to reflect the sorts of things that you say about traffic, how it is important to have it lined up right and rational. So Warren said, okay. Dan continues, we rearranged all the functions. We didn't expand or contract it, or even change its shape much, but we took advantage of its shape in a very different way, and the functions went in different places. That's because functions that needed to be in direct communication originally were across the courtyard from each other. Meanwhile, another batch of traffic would be trying to negotiate at right angles to that. So there would be trucks going back and forth across the middle of this big space, and they would be intersecting with trucks and vehicles trying to move down the line of places where you drop things off. The cross traffic would cut those lines and cause possible crashes and collisions. That's what we remedied. Dan continues in the interview speaking to Mark. And so you and I worked on that one. We got the site plans with all the dimensions from Warren by fax. The local Dunedin people were cooperative. They were okay with the redesign. We straightened it all out and made it a lot more useful. We turned it into a streamlined, linear thing where everybody worked around the perimeter and they never crossed. It was the same basic shape and design and size, but it was more logical and tied to the need to make recycling more both convenient and safe. Mark explains the site was a innie. The customer traffic went into the center and heavy truck traffic went around the site on the outside. We had to completely redo the traffic just to get it to work. I remember working on that and adjusting my drawings to recognize that in New Zealand, they drive on the wrong side of the road. So I had to make sure all the traffic was all on the wrong side of the road. I got it all drawn up that way and sent it to them, and then realized, oh no, I had put all the solar collectors facing south, not realizing that the sun's in the north. Through all of this in the interview, Dan's laughing. So I had to go back to my studio and change all that. Dan said, it was a little tricky working on the other side of the world below the equator. And Mark adds, I was paying such attention to the cars on the wrong side of the street and working all that out, and I got about halfway done when I realized what I'd done and stopped. Well, Dan's interview with Mark Gorrell is full of gems and touching reminiscences, and we'll hear more stories from it in the future. As Dan describes it, sociology and architecture is an unusual combination of disciplines for a field normally and exclusively reserved for solid waste engineers. This is a story of how a pair of design collaborators seized the opportunity and had a decisive impact on the transition from wasting to material recovery. Zero waste site planning started in Berkeley and spread all around the world.
Thank you for that, Susan. Thank you for making the show go on. I'm going to ask Dan a question in a moment. The fact that we don't have Mark with us tonight sort of illustrates again why the archives is important. We have, in past months, we have had people who have been featured who actually were available to answer questions about their life and work. During the time we've been doing this show, 3 of the people that we've featured on the archives that were there to be interviewed passed away within a year after. The most recently, Jay Wexler, Max's dad, and plus Warren Snow, New Zealand, and Will Bax. So it's important that we preserve these things. Dan, without Mark being here and with his wife not being easily available, you're kind of the next best thing to talk to about what Mark might have thought and did. And I had an advocacy question. Architects have to get their projects approved. And I found that Mark was especially effective at getting people to do stuff. And it wasn't just about going to the city engineer and saying, you're wrong about the tonnage of this and that, or you're just wrong. He somehow was able to overcome that and get people to do what he wanted them to do. So I'm wondering, from an advocacy point of view, what did you observe that made him especially good at that?
He was tenacious. He had a very good understanding of how the city worked. That's because he wasn't just an architect for recycling at all. He did a lot of other things. And in the course of doing other things, he went a lot to the city because he had to talk to the planning department. He had to talk to the about permits. He had to get permits. He had to work with all sorts of people in the city bureaucracy. But more importantly, he became really familiar with the people at the very top, including the city manager. And I remember there's a part of one of his interviews where he talks in some detail about how he worked with the city manager, and he said, I never told him what to do. I always told him what would be essentially the consequences of a decision one way or another. He had to make the decision. He had to live with it. And I found that that was the best way to do things, but I never, ever told him what to do. And he said, I asked him, how long would you be with the city manager when you went to see him? And he said, well, the average was probably a half an hour, but sometimes they went longer. Well, that's a long time for an unpaid lobbyist to have with an extremely powerful person. And I can tell you the outcome of that story. That story had to do with Ecology Center's embrace of dual stream when they were being pressured to do more automation. And how are we going to do that? Well, the solid waste people at that time didn't want to pay for it. They said, no, we don't have that kind of money. We're not going to invest in those split carts. And Mark went to the city manager and told him what the consequences would be. And a couple of weeks later, the city manager called him up and said, you can have your carts. And by the way, Mary Lou is also part of this group of people. She's with us tonight, and I want to make sure that she gets a chance to weigh in on Mark Gorrell too, because we were all best friends.
We were best friends, and I wanted to say one thing about Mark. Echoing in the same room here. Mark, one of the things about Mark was he never directly contradicted someone, the way Dan and I have a sort of pattern of doing, and people whack us for that. And Mark did not get whacked because he didn't just say you're wrong. What he did was what Dan said. He said, well, the way you're thinking about it is going to have these consequences. Another way of thinking about it, or he would show them possibilities. Another way you could think about it is this other way, and the consequences of that would be this other thing. And he would present their way of thinking as having really negative consequences. And he would offer the option of thinking differently, which would have wonderful consequences. And then he would leave the decision to them. He was very
Sounds like he
effective.
should have been a lawyer.
Pardon?
He should have been a lawyer.
Oh, no, he would never have. He'd have kept. Oh, gosh.
You're muted, Dan. You're muted.
I'm sorry. I had to browbeat Mark into getting paid. He was a person who was much more interested in ideas and in process and getting things done than he was in getting paid. Somehow he always had money. He always had more money than I did, even when we were freshmen in college. But that was because he was frugal.
He was a skinflint.
He's a wonderful guy. I miss him every day so much.
Well, I think like Susan says, there will be future episodes where we'll talk more about Mark. I want to transition to bring in our guest interviewee.
I'm sorry, can I say one more thing about Mark?
Sure.
In terms of legislation and being a lawyer, he helped write a lot of local ordinances. and he worked on a couple of statewide bills, and he asserted that every piece of legislation should have exactly the same last provision, but not if it's stupid.
I'd love to see that written into an ordinance. So with us tonight is James Ferrier. Hopefully I pronounced that correctly. All the way from New Zealand. Not the first New Zealand person we've had to interview. We've had Warren Snow, which you may have been acquainted with. But James is the CEO of BioFab, which is a company in New Zealand that is going to be making products from mycelium or fungi, or however we can try to pronounce that. So James, my first question to you is, how in the world did you come to the business of mushrooms?
Well, definitely not through any type of guessable or typical sort of route. And firstly, hi everyone. Thanks for having me on the call tonight. Definitely excited to be here. Coming all the way in from New Zealand. So kind of my background into it was I kind of went through school as very much a C's get degrees student. And I was actually sort of a rugby player. So up until I kind of got into business, all my intentions were to be a professional rugby player. Had a few concussions and that, realized that, rugby is any sporting career is a short career. It's even shorter when you have concussions and are playing a contact sport. So I decided to kind of follow in the footsteps of my old man a little bit and get into what was industrial packaging. So a lot of sort of engineered packaging for steel industry and postal and things like that. Sort of pretty soon after that, I sort of realized that I wanted to do, earmarks, sustainable packaging. And I was sort of limited to what I had available as a trader or an importer, which is largely just sort of PLA plastics, bioplastics. Sort of realized that even that wasn't going to be a silver bullet kind of a biopolymer to solve all of our plastic woes. And there are obviously, sort of nuances even with that material when it comes to composting. But I kind of realized that I needed to be at the material development side of things if I really wanted to be sort of selling, truly better packaging material. I had also 150-year sort of family history working in the wool trade in New Zealand. So sort of had in my bones and blood a lot around natural fibers already and understanding the value that they have. Had a friend of mine in New Zealand that was setting up an industrial hemp company also, which I got involved with. So I was sort of out there kind of being like, hey, I know a bit about packaging. I've got a drive. I want to make things from sort of natural fibers. I've got involved with this industrial hemp company. And I was sitting here being like, okay, well, what are some opportunities that I can do to drive some high value sort of end products to help that hemp industry grow? Then through sort of a mutual acquaintance that invited me to a chat where there was a guy, Andreas Merschen, who's now one of our scientific advisors. He's from the Center of Bits and Atoms at MIT in the States. He was in New Zealand giving a chat about a range of the technology he was working on. And one of those bits of technology was the mycelium composites. So literally, I think within 2 hours of hearing about mycelium composites, I decided that I wanted to start a business in it. So that was how I kind of got into it. So absolutely no formal background. I actually dropped out of university 3 times before I realized that it wasn't for me. So we have some commercial mushroom growers and mycologists and things like that in our team as well. I understand a lot about it, but I'm definitely by no means have come through a traditional sort of either sort of research university or mycologist and mushroom growing background to get into it. But absolutely now I'm a evangelical supporter of fungi and what hemp can do. And I sort of try to pick the right crowds to say it with, but I normally like to sort of say that we're using cannabis and cannabis and mushroom to save the world, but the industrial types.
So it sounds like, and correct me if I'm wrong, is that you have a family background and an existing infrastructure in manufacturing. And because you ended up feeling that the things you were making weren't very, very sustainable, you like the idea of an alternative product that you felt would be more promising that way. Is that kind of how
Pretty much. There was a lot of like my family history in wool. My old man had gone into supplying a lot of steel scrap into the wool industry, so he was acting as a trader, largely importing a lot out of sort of Asia and the United States into New Zealand and Australia. So although my old man had gone down the more trading route and less manufacturing himself, very much had manufacturing in my bones. And absolutely sort of felt like the only way that we were going to really create some unique opportunities was by not waiting for China to increase their production of biocomposites, and that actually New Zealand has a strong history in natural fibers and high value natural fiber products. So I thought, why can't, down here in New Zealand, we look to try and grow this technology to hopefully make it more accessible throughout the rest of the world.
What kind of facilities does BioFab have in New Zealand?
So right now we have very sort of like limited in the way of facilities. So we're currently raising capital now to build our first commercial scale production plant. That would do around sort of 1 million sort of units per year. So right now we have 2 like small scale production facilities. One up in Auckland, which is where I'm based, our more recent one, and we have another one based down in Opotiki, which is about 5 hours drive south of our main city. But that's where our mycologist is based. So for our first couple of years, we were producing close to where he was.
So it sounds like you have a couple of R&D facilities until you raise the capital to upscale it.
Yes, and so we are actually working with an American company called Ecovative. So Ecovative Design, which is based in upstate New York, they are the global leaders in this mycelium technology space. And so we've been working with our own fungal species, but with their manufacturing technology. So we know and we've seen that larger scale production, and we're going to be, leveraging that Ecovative technology to build a relatively large, we're taking a pretty large step going from small scale or pilot to full scale commercial production. But we're absolutely leveraging the sort of the decade worth of commercialization that Ecovative has done in the States to kind of de-risk that big jump.
So you mentioned that New Zealand has a culture, based upon fiber, wool fibers, animal fibers in particular. Is there something else about New Zealand that is making mycology an interesting, career? Are there swarms of biology?
Absolutely. And I mean, and when we're talking about sort of the short term compared to the rest of the world, New Zealand and Australia are kind of as an entire nation are kind of really quite forward with our regulation around hard to recycle plastics. So that makes it a great regulatory environment that's driving the adoption of these new materials. States, every state can be like its own country is how we think about it in New Zealand. So we're probably much more similar to regulation that's in California compared to other parts. But on a deeper level around sort of mycology as a whole, New Zealand is geographically has been a very isolated island nation compared to the rest of the world. And we have a very unique set of flora and fauna. We've also had a lot of that quite well protected through what we call taonga species, which is native and endemic species of plants and fungi have been quite well sort of protected. So there is, when we look globally at, I think it's called the Joint Genome Program or project, which is, there's a number of nations that are signed into that, where they're sort of doing wide scale sort of scouring through fungal species, looking for value within them. We haven't been part of those programs. It's actually our Land Care, which is one of our sort of Crown Research Institutes that holds our national fungarium or library. It's only been the last sort of 5 or 6 years that they've actually been keeping a cold storage, like living culture storage of fungal species. So we know very little even about our own fungal species, then let alone what the rest of the world knows about the value that might be within our unique fungal species. So we're really hoping that, although we're a small nation, from a technology export point of view, that we potentially have some really unique value within our fungal species in New Zealand.
So instead of being Silicon Valley, you could be Fungal Valley.
Exactly. It's so funny. Like, so often we have people in New Zealand try to say, let's make New Zealand, like a Silicon Valley. And I'm like, I love the intent of that, but why do we need to copy it? Why can't we make it our own version of something that we excel at doing? And absolutely, I think, green technology is something that, I really hope New Zealand can be a sort of a great place for homegrown technology to expand from, and that we can also be a great market for technology to incubate in. We generally have sort of, well, not now after the last couple of years, but we've had relatively low cost of living. We've had a high standard of living, very sort of beautiful and enjoyable country to live in. We're very good at bootstrapping and doing things with what we call our number 8 why mentality, which is we can be very innovative on the cheap. And now that the world's had a crash course and working remotely over the last 2 years, hopefully some of those things that traditionally has made it hard to work with New Zealand or connecting New Zealand to the globe, some of those things have been probably reduced over the last couple of years. So we definitely want to make New Zealand, not just this commodity exporter of milk, cheese, and honey. We really want to, try to transition our economy to be like a high value and technology export country.
And you've still got to get the stuff to market.
Got to get the stuff to market, and that's where it's, like, we can be a great market to test things, but we're a country of 5 million people. We're a small market, so we that's one thing that I think is always really sort of outstanding of Kiwi founders and entrepreneurs, is that we've always been driven into us from day one that we need to think global from day one, because we know that we can never rely on our own market to sort of, grow a really impactful business from. Obviously Australia is a bigger market that's right next door to us. We can leverage the fact that New Zealand and Australia are the only 2 Western nations within sort of Asia Pacific. There's quite a strong link that we can play between both worlds there. But places like the States, like, we're now really sort of starting to look for American investors into our company, because we've struggled to find Kiwi investors, and we think that we're seeing a lot of American investors put their money in New Zealand at the moment. So it's we're starting here, but we're absolutely sort of thinking global in terms of the impact that we want this technology to have.
Well, you've got people on the Zoom that are a variety. We have a number of people who got excited about mycelium when Paul Stamets wrote his book a long time ago. We also have people who are, as we speak, are in the process of trying to design single-use food ordinances that restrict the kind of materials that can go on these single-use products. So the key question on a lot of people's minds here is this stuff that you're going to make really compostable? Or is it just another plasticky kind of thing that isn't?
Yes, and only because of the way that question was asked, I would say, like, yes, it is different. But normally I try to tell people, like, I never want to say it that simply. So kind of my background is that I've GrowPack, which has been more my sort of trading sustainable packaging company. We've been selling products like PLA and things like that. and one of my business partners is his old man owned one of our sort of largest recycling companies in New Zealand. So have a very, what I think is a pretty good understanding of what it actually takes for a material to be compostable. PLA and some of these biocomposites, at the end of the day, they can sort of act as a neutral filler, and they can normally only be added in at about a 5 to 7% mix ratio in a traditional compost. This isn't, I'm saying this from the current perspective of commercial composting, not to say that commercial composting won't change to better work with these biocomposites. But mycelium composites, it is not a biopolymer. It is a composite material, and I hate using the word natural, because at the end of the day, what does that mean? But if we look on a spectrum of looking at a traditional sort of plastic as being sort of up here on the synthetic scale, and that we look down here at sort of, incorporating back into soil itself being natural, mycelium composites sit sort of right down here. And that's because their composition is, we make ours out of hemp hurd as the base composite. We use, it's about 2% of the final masses of mycelium. We add about, a small amount of flour as a nutrient source, a very small amount. There's obviously water that gets baked off by the end of the process. And that's literally it in terms of the inputs. So we've had our nutritional profile tested by independent labs. We've sent that to commercial compost, and they've said, like, hey, based on this nutritional profile, this is actually sort of the level that we would pay, because we're using spray-free hemp as well. It's something that they can put into their high-value compost. So I can talk for much, much longer around all these nuances with it, but because I never like to round it off by just saying, yes, this is better than other plastics, because we live in a world where there's been a lot of greenwashing of things over the last decade. So things are never as simple as what they say. I also like to round it off by saying that mycelium composites are not going to be some silver bullet, though, for all plastics. They're not even going to replace every single type of expanded polystyrene or other expanded plastics. So when it comes to looking at, solutions for moving us into a better direction, mycelium composites has, I believe, a role to play, but, high value reusable products that can be made from plastic, recyclable plastics, things in New Zealand, we have a lot of PET recycling in New Zealand. So I'm big whenever I talk about how evangelical I am about mycelium composites. I always want to make it very clear that there's only sort of one tool in the tool belt in terms of moving into a more positive direction.
So let's talk about the products that you're going to be making. And it sounds like you've got a packaging background, so it would seem natural that you would be focusing on alternatives to plastic packaging, whether it's, the little films that wrap around the cannabis containers or what have you. Is that the focus?
So but protective packaging is definitely our focus, sort of go-to market. This is a material technology. Just like polystyrene can go into many markets, so can this. But where we've seen a lot of the adoption now has been in like protective packaging for high-value cosmetics, homeware, luxury items. We're seeing in the UK a lot of usage on like sort of appliances, oil fin heaters, and things like that. I've seen there's a company in the UK that started using that. That's quite a large company. So broadly speaking, protective packaging is where this material performs really well and can act literally as a drop-in replacement. Industrial packaging and restraint packaging as well. There's a lot of opportunity there. Construction products, there's a lot of interest there as well. But in terms of the short term, packaging is where we should be putting the focus. Single-use packaging is where we should be putting the focus with this material.
So I don't suppose you have anything handy, but can you describe what the look and feel of the protective packaging is?
Yes, and it's a and I'm so sorry. I do actually have a sample in my car, but it's probably about a 2 or 3 minute run away. I can actually share my screen, which might be the next best option, and actually give a slightly more high quality image.
Bonnie, do you need to make him the host?
Share.
I don't need to be the host, but if you might just need to sort of grant sharing access.
Yeah, you should be able to now.
Cool. Okay. So I've got that up. Let's go share screen. And scroll through down to our use cases. So these next couple of slides, these will show sort of some of the use cases. So if I zoom in here, I'm not sure how clear this will be coming up on your guys' end, but you can kind of see here a broken piece of the packaging. So you can actually see sort of the individual sort of wood fibers or wood chips that make it up. All of the white surface that you see to it, and that also is binding, growing through all the wood chip. That's the mycelium. So the mycelium is the sort of the root, well, it is the root structure of a mushroom. The easiest way to think about mycelium is that a mushroom or a fruiting body that we normally know of is something that we might eat. A mushroom is made up of mycelium, but mycelium does not always present itself in the form of a mushroom. So before it goes into its reproductive state and produces that fruiting body so it can release the spores, it is growing as this dense fibrous network through the ground or through a tree, or through any type of sort of biomass on the forest floor. So mycelium is a...
So I'm looking at these pictures, and I don't have the best eyesight in the world, but it looks to me like these products kind of mimic a styrofoam packaging. Do they look and feel like that?
Exactly. And styrofoam or expanded polystyrene is really what we simply say to people when we say this is what this material will replace. That's what we're saying. There's obviously other expanded plastics out there, but expanded polystyrene is one of our most common materials that we're replacing.
So the simple key question is, if I order something from Amazon and it comes to me in one of these protective packaging products that you make that kind of looks a little styrofoam, am I going to feel good about putting this in my green can?
Yes. So for one, you're, as much as it looks like polystyrene on the photos, you are absolutely not going to mistake it for polystyrene when you hold it in your hand, just from the feel and the texture of it. And obviously when you break it, you'll see that wood chip in there. And then when you, pardon?
Is it heavier than
it is slightly heavier than your lightest densities of polystyrene. So we're using hemp, so that's around a bulk density of about 100 to 110 kgs per cubic meter. Polystyrene packaging will normally be around that sort of that 32 to sort of 40, 50 kgs per cubic meter. So it is more heavier, but it's still a very light material.
Why am I going to feel good about putting this in my green can?
So you're going to feel good about it. One, because the production of this product has used, completely renewable resources in the production of it. We haven't taken any sort of fossil materials out of the ground to produce it. And in producing it, we used a lot less energy and we have a lot lower carbon footprint. When it's an actual waste product and you have to do something with it, it's actually, very easily home compostable, for one, which, can't be said about other biopolymers. It's actually contributing nutrients back to that compost or to that soil. Another sort of little thing here that I always like to add is when we talk about compostable, it's sort of becoming, there's even confusion forming around this world. So I always like to say that this material is compostable when we talk about the certifications. So ATSM 6400, we've got similar ones. We use the Dinserto one in New Zealand and Australia. Australia, we have our own one over here, and we also accept the European compostable standard. And assuming that they're all roughly the same, this material under the certification is compostable. But what we like to go a step beyond that and say that it is marine and soil biodegradable, and that it will actually biodegrade quite rapidly in those environments. And I guess how I kind of phrase it is that it's biodegradable in terms of what an end consumer thinks that word should mean. It hasn't got any fish hooks. It doesn't have to go into commercial compost. It doesn't need sort of 50-degree temperatures to actually start breaking down. And again, I always say I hate using this term natural, but in terms of it incorporating it back into a product or material that can easily go back into nature or back into your garden, it very easily can convert itself back into valuable soil in that regard.
So you mentioned the regulatory environment, and I think you're right. California is definitely heavily regulated. If New Zealand is similar in scope, and it sounds like it is because you use the same ASTM 6400 standard. I read that a long time ago, and one of the features of ASTM 6400 is that it has to be acceptable at a compost facility. So if I put this in my green can, is the composter that gets it going to say, what the heck? I don't want this stuff. Get this out of here.
Now, I never want to say a blanket like, no, they won't. So at least speaking from where I've gone and tested this in New Zealand, we have about, I think it's like 20, 28 or 30 sort of listed commercial composters. We have about 13 of those that say that they can accept certified compostable packaging. We only actually have about one, maybe two, that are actually accepting soft film plastic PLA. This material, we have taken this to the commercial composters, and they have all said that, yes, we want, they're not saying that we just can accept this material. We want this material in our compost. We also have in New Zealand what we call our green top curbside collection bins. So these might go to a anaerobic digester or other types of sort of waste management solutions for green garden waste and things like that. This can go into those. So in New Zealand, we differentiate between commercial compostable and curbside collectible in a green top bin. It's a much tougher set of sort of requirements to be acceptable in that green top curbside collection. We've had now there is no precedence for packaging going into green top curbside recycling. Collection. Simply because no other commercially compostable packaging materials out there on the market can be accepted into them. So there's no certification around for this right now in New Zealand, but we've had councils in New Zealand say that this material is even safe to go into your green side curb collection bin that is normally reserved just for garden trimmings and things like that.
Well, I would guess that even more stringent than the green bin standards would be the home composter standards. So to a home composter, are they going to put this thing in their home compost and still see it whole in 3 years?
And yes, now again, from talking to people that have a composter, and you're dead right, in terms of that individual that really cares and knows how to home compost and they really care about their home compost, that is absolutely going to be the stringent sort of person or individual that you have to get by. And this is something that can absolutely go into it. Its end composition is 98% of it is the hemp herd, which can be a great material for compost. That extra 2% of that mycelium mass, I guess, would be treated as like a bit of like a food scraps going into it. Now Now, a caveat here is that when we manufacture these materials is that we want to always try and include agricultural waste sources. So right now, our packaging product uses a 100% hemp hurd or hemp pith core to it that we grow the mycelium through. If we're using corn husks or spent grains from a brewery, and we start to use other types of agricultural waste sources, what we're talking about might change, because as we use different types of agricultural waste sources, it's going to change that nutritional profile. But absolutely based on at least using our hemp hurd base. And I can't speak for every home composter out there, but from my sort of, understanding that's only a little bit more than the average person, it's very highly acceptable. And it's as close as I've seen to making a blanket statement of that. This is widely acceptable into most forms of composting that we can think of, whether that be home or commercial or anaerobic digester or whatever.
I have a couple of more product questions, but before I ask you that, I want to. It sounds like you use a lot of organic materials, hemp and other agricultural sources. What is, without getting too much in the biology, what does the mycelium do to add that to make it worth adding it?
So the mycelium is, so each little individual fiber, which is called a hyphae, the collective group of them is what we call the mycelium. They're like a little sort of, you imagine them as a little sort of worm-like sort of a thing. So they will go through, and as they search for nutrients, they will come into a bit of hemp hurd or wood chip, or they hit it. They recognize that as a food source. They'll release a particular enzyme that will just break that wood chip down. And it does that so it can break apart the bit of nutrients it wants to consume. And it will just keep growing along, burrowing through and around it. And so it's really like a micro manufacturing plant. There's a lot of manufacturing that happens with industrial enzymes and large industrial processes. Really, this is doing the exact same here as how we might prep paper for making prep pulp for making paper. It's just happening on the microorganism scale.
So you're putting.
And sorry, that was my old man. I'm currently taking the call at my old man's house, hijacking his office for the hour. So apologies for that.
So going back to the products, that I see this protection product, as you call it. Are you intending to make other kinds of protection products like the films that go around, cigarette packages or utensils, anything of that nature?
So it's like yes. In terms of like long-term thinking, we have so many ideas within the incubator group and within ourselves about how we can develop these mycelium materials to have, a wider range of plastics that we could replace. Now, everything that you see here and most of what you will see currently in market is what we call the composite grade. These here are like protection edge protectors, sort of like restraint packaging. Down here, that's not made from mycelium, but that's large polystyrene billets that get used for the sea freighting of steel coils. But all of these examples right here, what we call the mycelium composites. And that's because we're growing that mycelium through that wood chip and we're making a composite material. When there is some of the technology around this, which is at a much earlier stage, is producing like the pure mycelium. Now, I'm not sure if that would be used to, say, replace like the film, the cellophane that might go around a cigarette packet, but absolutely it can branch more into high performance foams and potential sort of barrier protection, and replace some more of the branch a little bit more into that flexible film space. An interesting thing actually about cellophane is that the reason that it's called cellophane is because it was originally created using cellulose. There's a fascinating story around cellophane that it should go back to its more natural state. But we'll save that for another time.
So to ask a composite question, are you getting government support for this project? And on the other end of the thing, are you getting opposition from anybody to this kind of technology?
So there is a lot of government support out there, and that is growing. I'm actually moving to Sydney in Australia next year to really look to build our first commercial plant over there. One of the reasons is because the Australian government has a lot more grants for commercialization. New Zealand has a lot of grants, but it's more for research and R&D. So it definitely feels like our government putting a lot of regulation around hard to recycle plastics, and rightfully so. They're putting in funds and large pockets of money to help support the transition away from those. And a lot of that is going into the development of new materials. In terms of sort of kickback, we have very little kickback in terms of like the adoption of the material. And I think that's largely because this is one of the sort of the few examples out there that is currently actually at commercial scale and in market that is truly compostable and biodegradable. It hasn't got some of the same fish hooks as some of the other biocomposites. So we have less sort of kickback from the existing plastics industries on it. But some of the biggest kickbacks that we get from like investors and things is like, will this continue to scale? When you hear, that we're growing the product, most people think, oh, how could growing a product ever compete with the commercial scale where plastics is currently at? And we normally point to people and say that the commercial mushroom growing industry is actually a very large industry globally. And we can look there for some examples of how this might scale. So there are places where there's a little bit of kickback. There's a load of support, but I'd say most of the kickbacks are typical things that you would expect when a technology is in its infancy, in early stage. And yeah,
I'm going to ask one more question, and then I'm going to turn you loose to the crowd, who I'm sure has a number of questions. But could you take your screen share off, and before we do that?
Sure can, and I'll just make sure that got all the photos out. The one other one that's a shocking photo of it, when we heat press the mycelium, that composite material from that expanded polystyrene grade, we can heat press it into sort of a engineered wood product. Now, IKEA and companies like that are looking at using that within sort of core board for furniture and things like that. That's another really interesting space of where the material's at. As well. But I will stop screen sharing.
Yeah. I would love to put some of my old IKEA furniture in the green bin, but I guess we're a ways from that.
Yeah.
So the last question is, you say that there's not a lot of kickback, but at the same time, you're telling me that there's government grants for people to promote alternatives to plastic, which is a good thing. But surely the petrochemical industry is right there, and they're going to tell the same government that you're talking to that, wait a minute, we're going to do something much better and much different than we've been doing before. And these amateurs over here with their mushrooms, you really shouldn't bother with them, because we've got money, they don't. We've got experience, they don't. We've got access to markets, they don't. Give us the money and let us develop this wonderful plastic melting technology, for example.
And
Don't you get that?
in some cases of different polymers, I would say that's absolutely almost like sort of true. And we should encourage the existing plastics industry to get a shitload better, frankly, at recycling and making products more recyclable. A little sort of cool story, I guess it's anecdotal, but this individual kind of represents 50% of the global production of polystyrene. During the America's Cup in New Zealand, so obviously the Great Britain team, which is sponsored by INEOS, was down here in New Zealand. INEOS is one of the world's largest plastic producers. I think in 2021, they were the world's largest company because of the increased use of plastics through COVID. we got to sit down and have an hour with the CEO and the head of operations of the styrene division of INEOS. That's a $10 billion alone division within INEOS. It represents about 45 to 50% of the global production of styrene. They said to us that in the next 5 to 10 years, we're going to lose 10 to 15% of our market. They said that for the first time ever, they are not at the round table with the government advising on the regulation around this. And they came to a view that what is the point in us trying to fight for that when we know that we're going to lose that amount anyway? So actually, let's almost get behind supporting that transition rather than fighting against it for that 10 to 15% market change. Now, the head of operations, who was also in the room, he had another very interesting view. And he was like, it was his job to also look at the technologies that in 50 plus years might cannibalize our business model. So it was very interesting seeing, even in just the last couple of years, they've even got, literally one of the world's single largest producers of all plastics, but particularly polystyrene, saying that in the short term, we know that we're going to lose 10 to 15% of our market. We're not even going to bother trying to stop that. And we're actually going to support that transition. And I'm like, hey, 10 to 15% of that global $25 billion a year polystyrene market, achieving just being able to supply that amount in the next 10 to 15 years. I'm like, great, there is more than enough space to play there. But they are also thinking in that long horizon, 50 plus years. They are very aware that if they put their head in the sand to these technologies now, that they might risk, the Kodak story is one of these traditional ones that showed of how a dominating player in the industry lost a huge amount of market space because they maybe didn't adapt with technologies as much as they could have. And that's that exact example that they gave us. And they said, we are absolutely aware that right now, we're at the risk stage of actually becoming a Kodak. Because 20, 30 years from now, we can't change our business model then. So I thought that was some interesting insights, and it was anecdotal, but it was from a couple of individuals that were very senior people in a company that represents a very large share of a particular part of this plastics market.
Well, I'd like to say I believe what they told you, but as Shakespeare says, beware of Greeks bearing gifts.
Yes.
So I'm going to turn it over to other people to ask questions. If you would use the raise hand feature, that way I can know to call on you. And I'm sure everybody has some questions to ask. Mary Lou, do you want to start?
Yes, I would like to know. You had a product there. The first product you showed us reminded me of an egg carton turned upside down. I'd like to know how long it takes to grow that. And I would like to know how much space, because this sounds like a real estate investment.
Yes, definitely. And so the total process from start to finish in terms of raw material turning up at our doorstep to end product coming out the end is about sort of a 10 to 12 days. The actual growth stage of when we actually put that material into its growth mold, it's about 4 to 5 days that it has to grow inside that mold there, which is a long time. But that happens at ambient room temperature. So there's no pressure or heat or cold temperature or CO2 environment involved. So it does use a lot of space, but it uses very cheap space to do it.
So does that means that you can occupy industrial properties and you will design your facility so that you can have a lot of trays layered like that growing, you'll maximize the use of your space because every unit takes a long time to produce.
Exactly. And it's essentially the more central we are, probably the more vertical we're gonna grow. And but the further away we go, we can just need literally just a concrete pad with with just sort of some insulated panel buildings. We can also go for very cheap land that might be further out of that city centre as well. But absolutely in the future, and that's hopefully where there is still so much innovation that needs to happen with this material. Like that's probably an important thing to say right now, is that the current state of this material in its current state will not go on to scale to replace all polystyrene. But that's also based on an assumption that we're only right at the beginning of understanding this material as well. So we're very hopeful that continued innovation around this might continue to sort of solve or mitigate some of those things as we grow. So unknowns there, but those unknowns are also the exciting thing for us to innovate around.
Oh, it sounds very exciting. Good luck.
Thank you.
John, did you have a question?
Yes. Thanks, James, for your presentation and your talk. And it seems like that based on the variety of applications that you might have and the number of different companies that would use it, it seems more like you'd be exporting your proprietary technology rather than exporting the actual packaging around the world. Is that sort of the goal?
Well, yes, and I mean that's actually what we've done from Ecovative, is that we've imported their technology so that we can manufacture to our domestic markets here in New Zealand and Australia. One of our big goals is that we really want to take this technology into parts of Asia, because that's where there's a huge requirement for this technology to be on the ground as well, because there's so much manufacturing that happens there. So no, you did right. It's just exactly the same economics as to why we don't export finished polystyrene packaging around the world. We export those pre-expanded beads, but it will normally be thousands, even though there's only a couple of companies in the world that produce those polystyrene beads, thousands of end converters are around the world. So long term, we're actually trying to think, how can we position ourselves more as a raw material supplier that can work with people that might do the end production in those local markets. Because we also think it would be foolish for us to think that we could be one company that could be experts in taking to market commercial, consumer packaging, industrial packaging, construction products. There's a lot of food technology around this as well. So we're definitely trying to sort of pick ourselves as being this raw material producer, and we want to work with existing packaging manufacturers in our markets to potentially help, finish out the supply chain.
Susan, do you have a question?
Yeah, you mentioned, especially like with that first product that you showed, wood chips, and I'm wondering what role wood chips play and whether that creates problems for forests.
So right now we are, I always kind of say wood chips are the sort of definitely oversimplifying it. So that's one of the reasons why we're using hemp hurd at the moment, because as a woody chip or a lignocellulosic sort of raw material input, it is something that it doesn't require us to be cutting down forests. Absolutely, it's like a no-go area would be like old growth or forest and things like that would be a no-go area. Even fast-growing forests like poplar and pine and things like that, it's still something that we don't like. We want to be taking sort of byproducts of existing industries, and using the hemp hurd is getting slightly closer to using what might be a virgin material. Although it's the lowest value part of the hemp plant, we kind of have a thing in the industry where we're like, no part of the hemp plant is a waste or a byproduct. It's all got value. But that's why we want to really sort of promote the use of things like hemp or kanath, these types of crops that can be grown in cycles with existing farms, and hopefully our supply chain won't ever require a sort of a monocropping model to gain our raw material input. But absolutely, again, like, if this technology alone was going to solely replace polystyrene, decades into the future, this is just one of these very real things that we need to think about now, so that all of our good intentions of moving into a better, more sustainable world don't just create bigger or other problems in the future. But what you exactly mentioned right there is something that we keep very aware about now.
So what is the role? I'm still unclear on what is the role that wood or hemp or calf would be playing in this. Are they the nutrition to grow the mushrooms to begin with?
So twofold. So one, nutrition. They provide a nutrition source for that mycelium to grow. We only ever have to inoculate it with a very small percentage of mycelium, and it will self-grow. But two, structurally. So that wood chip that we use, or the chip of the feedstock, that has structural integrity for the composite as well. So it's twofold in that regard.
Thank you.
Any other questions for James?
Are any of your, here, just a second. Sorry.
You're muted.
Oh, Dan, I think you're back off now.
There you go. You have feedstocks that come to you. How do you get those feedstocks? Are people paying you to take them?
So right now in New Zealand, we're using hemp herd. So my background was actually I'm involved with a industrial hemp processor. So we get those from the industrial hemp processor. Other places in the world that are using other types of sort of feedstock, like corn husks and spent grains and things like that, they source, there's every single feedstock will have a unique sort of sourcing from it, or route to source it. So the ideal thing for us is that every little sort of manufacturing plant would have more of a distributed manufacturing model instead of building, one massive mega plant. So that means that in each area, we can make sure that we're sourcing that feedstock locally. Now that has a great impact for, the carbon footprint, but it just financially and economically makes sense as well, because we spend less money freighting our raw material feedstock to us.
Okay.
But to give a real world example,
maybe I didn't quite make myself clear. I was thinking that the feedstock is something that your hemp producers are having to get rid of now. And do they have to, what are the other places that they can take it? And what does it cost to get rid of it? If they take it to a composter, how much do they pay? If they take it to you, how much do they pay? Or do you actually buy the stuff? Or what's the economics of handling the feedstock?
So we're buying our hemp feedstock right now. So hemp herd currently is going into things like animal bedding, and that's the main thing that's actually being sold into now. But there's a lot of sort of growth happening in things like hempcrete and other things like that. So I don't think hemp herd will ever be at a point where it's actually a genuine waste product. We might call it one of the lowest value parts of the plant. So out of all the potential available feedstocks that we could use, hemp is the most expensive. But it's also nutritionally, it's a great feedstock. The density of it being a very low density, it makes it great for packaging as well from a functional perspective. So we've actually quite liked that we're building our business model using possibly the most expensive raw material that we currently use, so that any inclusion of other raw materials or any growth within the hemp industry, we should only see our raw material cost sort of decrease from where we're at now. But yeah, absolutely, we're paying for it. It's probably the most expensive feedstock we could be used, but it makes one of the highest quality products that we could make. And we're much more focused on getting material into market and giving consumers a great product before we're concerned about maximizing profits or efficiencies.
Thank you.
So I don't want to interrupt the discussion, but I've moved my office and I'm told that if I am not out of here by 7 o'clock, I'm going to be locked in for the night. So I'm going to be forced to leave the meeting, but that doesn't mean anybody else does. I do want to say thank you to James for taking the time from down under to spend with us. It's been really interesting. Next month, we'll have the second Tuesday of the month. We'll have something about someone who's greenwashing. So tune in next month. Thank you again for James. I'm going to leave, but the meeting isn't over. Thanks.
Thank you, John.
James, this has been wonderful and very, very interesting.
Oh no, thank you. It's I still pinch myself sometimes that I've even got the opportunity to sort of work in this space. Like, as I said, being a 3-time uni dropout rugby player, that is sort of getting to sort of work with these materials. It's just so passionate and just love it. It's like it's a very exciting space to be playing in.
Well, we can take
Go ahead.
we can take a few more questions. I know, James, you're in the middle of your afternoon and you probably want to give your office back to your dad. So yeah, we can take a few more questions.
I've got easily another sort of 10 sort of 15 minutes. I've just got an appointment in 40 minutes that I need to get to, and that's only around the corner. So
Okay.
One thing I was going to ask you is, when you get over to Australia, have you ever run into a guy named Jerry Gillespie?
Gillespie, that sounds familiar, and I'm not just sure because there was a Gillespie that was a professional cricket player in New Zealand and Australia at one point. That might be why it's ringing a bell.
Well, he does composting using inoculants. And
okay.
Sounds kind of a parallel thing.
Did you say Jerry Gillespie?
Jerry Gillespie. He actually is in Queenbarron, which is a suburb of Canberra. Jerry Gillespie, Gellillispie.
I think I might have found a YouTube video from him. But if you've got a point of contact, I'd love to maybe Bonnie or I can leave my email address in the chat here to make an introduction.
I don't really know if he'd be able to help or if you could help him or whatever, but he's a very interesting man. He's a folk singer, among other things.
Well, I'm moving over there and I need to just form a contact. So even if it's just an opportunity for a friend, I'll take it.
Okay, great.
Any other questions?
James, I was going to ask whether you follow the trade magazines of the packaging industry and the petroleum industry, and it's fascinating to have a look at the other side and so many instances of the packaging organizations with a solution looking for a problem, and some of the stuff is just like horrifying what they're coming up with. And so maybe to take a look over on that side of the fence and keep learning and sort of cutting them off at the pass with your own solutions before theirs take hold.
Oh, no, definitely. And I mean, like it's so hard because not hard, but there's so much in that space between genuine innovation and greenwashing innovation and innovation that's well intended, and it's like there could have been something that was just developed yesterday and we haven't heard about it yet. So no, I always try to keep my ear very close to the ground. I've learned a lot, in that space to make sure, we have a motto internally within our business that we're like, never get comfortable. And one of the things that applies to is like, greenwashing. It's like, we believe that this material right now is a great example of a compostable material compared to others. But one goal is that I want to never make sure that we overclaim something, even by a little bit, because that will always be that thing that someone will end up focusing on and call out for greenwashing. So I try to look out for it in other people, and even on ourselves all the time. We try to make sure that we're checking ourselves on that as well. But hey, if you've ever got, I've chucked my email down there. So if you ever come across sort of technology, I'm a bit of just a technologist in general. So I just love looking at technology, good or bad, ugly or green or whatever it is. It's just fascinating, the amount of new technology that's coming out. And, if you've got to have kiss a few bad frogs before you find your prince, then it's part and parcel of us moving down this innovation path that we're on. Is that, you're naturally going to, so people coming out there with not always great innovations is probably a good sign that there's a handful of goodies in the mix somewhere.
Good on you, Mike.
Thank you. And great, fooled me there that you might have been Jerry Gillespie with that accent.
Yeah, my email is dr.ore@urbanor.com.
Bonnie, are you able to share those emails afterwards?
Yes, I can share.
Yeah.
Thank you.
Okay, good.
Well, I'm so glad that James, you were able to join us. And I think my YouTube algorithm, how I discovered you when I was watching a YouTube video, is mycelium fungus, the plastic of the future. And I was like, oh my gosh, I have to find him and like bring him on the show. So thank you, YouTube. But
yes, and Matt Ferrier, which I'm sure which was probably that video author.
Yep.
Undecided with Matt Ferrier is a great YouTube person to follow for cool technology.
Yep. That's the one. Well, I do have to end the meeting in 6 minutes. So if there's anyone who wants to ask a question before we close out.
I'd like to say thank you.
Yes, thank you.
No, and thank you for having me. And it's this is something that's probably a little bit more of one of the more selfish things that I do, but being on a capital raise and trying to grow this business at the moment, we are always on the lookout for networks and connections, whether they be partners, technology partners, investors, or anything like that. So, even if anyone wants to get connected to sort of Ecovative or some of the other partners in the other parts of the world that are working with technology, always happy to keep connections going and receive anything connection wise. So just glad to have been here and have got to meet some of you guys virtually. I'm hopefully going to be in the States sort of mid next year also. So would love to potentially try and swing by and who knows, come and check out one of you guys' sort of composting facilities in California or something like that. So we can stay in touch.
Yes, the Northern California Recycling Association is very connected with municipal programs and composting facilities of sorts. So we can definitely connect you.
Cool.
Mm-hmm. Awesome. Well, thank you, everyone.
Oh, thank you. And also very good questions, like very knowledgeable bunch of people. It's the amount of sort of experts that we even have in New Zealand that you can get a good idea of someone's understanding by the questions that they ask. So thank you for all the sort of very thoughtful questions that you put forward.
Sure.
Thank you.
Have a good night.
Thank you. Great work.